Hello again everybody, and welcome to yet another math video. In this video I will be going over the present value of an annuity, and I will touch on amortization. And really those are the only two things that I go over. Alright, let's get into it. The present value of annuities. So here we have the equation for the present value of an annuity, where PV is present value, PMT is the consistent payment that you are making into the annuity, 1 is just 1, I is the interest rate per compounding period, which means if you are not just given that information, you have to divide the annual rate by the number of compounding periods in a year. And N up here is the total number of compoundings, which would, again, if not given to you, you could figure out by multiplying the number of years times the number of compounding periods per year. Now with the present value equation here, we mostly use this when we're working with loans, and that includes credit cards. So the first example here will have no context, but we will go ahead and go through it just to get some of the mathematical mechanics down. So the present value, of course, is the payment, which we know is $231.45. And in the fraction here, we can have 1 minus 1 plus 0.003 to the negative 50 power. So that's different. If you've seen future value of annuities before, you have to make sure that it all gets swapped around. What's into the parentheses is the same. It's 1 plus I, but the subtraction that happens in the future value is switched around. It's this set of parentheses minus 1. And then the exponent is also swapped signs. This is negative 50, not a positive 50. So just make sure you're keeping that in mind as you go through and do these examples. 0.003. All right, so when you go through and crunch all of this out on a calculator, I would figure this part out first if you have a lesser degree calculator, and then multiply it by 231.45. So the answer should be $10,731.46. So if you took every payment you were going to make over the next 50 time lengths, whatever that is, right? We don't know if this represents months or weeks or days or whatever, and you discounted them back to today's money before they earn any interest, right? That first payment you make would make interest 50 times. Well, it's not making that interest, so we have to discount that backward. So we would end up with $10,731.46. Let's take a look at an example that has a more real-world feel to it. That'll give it a lot more sense in when this is used. For this next example, we are trying to figure out how many months will it take to pay off a credit card with a balance of $3,173.14 and an annual rate of 16.99% if you only pay the minimum payment of $75 per month. All right, so for this, we know this will be a present value formula because we're dealing with a loan. So here is the formula for that. 1 plus I to the negative n power all over I. Now, instead of going through all the math, I'm just going to pull a little math magic here, and you can take my word for it that if we solve this expression or this equation for n, it'll end up being n equals negative the natural log, right? Since we're solving for an exponent, there would have to be a log involved somewhere, and I've just chosen to use natural logs for this. 1 minus I times PV over PMT all over, what is this? Natural log of 1 plus I. And so this formula here will make it a ton easier to just put some numbers in and simplify down and get some sort of answer. All right, so in this scenario, you'll notice that we weren't given an I, we weren't given an N. Instead, we were given an annual interest rate, and we knew that it was going to be monthly. So 6.99% over 12, or 16.99% over 12 just means that I will be 0.1699 over 12. Which will be approximately 0.014158333. So anytime you see an I in this equation, we're going to put this string of decimals. So the present value here then we can see is pretty straightforward. It's $3,173.14. The monthly payment, or the payment here, will be $75. So we get to just start substituting numbers in and see what we get. So this is what it looks like with all of the numbers substituted for the variables. And I think what I'm going to do first is I want to simplify this fraction. So I'm going to simplify this fraction first and then multiply it by this decimal, which gives me this decimal here. And from here, I can just say natural log of 1 minus this divided by natural log of 1 plus this, and just make sure I negate the answer to get a final answer of 65.00013 months, aka payments. Now here's the funny thing about credit card payments. Unless you hit it exactly, right? This is 65 and a little bit more. It doesn't matter how much more it is. It could be 0.000013. You have to round up to the next payment. So technically speaking here, if you only paid $75 per month, at the very end, you'd probably have like a penny left over. In reality, you would probably just pay the $75.01 left over. But mathematically and theoretically speaking, if you're only going to pay $75, you don't quite meet the requirements to pay it off in 65 months. So you will always round up to the next whole number, and this would be 66 months. Now, a few more thoughts about this. So the final answer here would be 66 months. So the next couple thoughts would be, just take a look. We pay $75 per month for 66 months. How much money did you actually pay to pay off this credit card? Well, we could just take the actual payment per month, the $75, and multiply by the $66 per month, and you would get a total of $4,950. Well, that was a lot of extra money that you paid for the $3,173.14 balance. That's the total amount, which means you could take the total amount and you could subtract your present value 3173.14 to figure out how much interest you paid. And at this point, I think I would rather cry than explain to you how much interest you paid. One moment, please. Let's see here. It looks like it would be $1,776.86 in interest, which is just way, way too much money, which just goes again to show you that you shouldn't pay the minimum payment on a credit card. One other thing I can point out is that you could be asked at some point in the future to convert this over to years. And if you were going to do that, you would just divide this amount by 12. And luckily, you'd get something nice this time around. It would be 5.5 years. Okay, let's take a look at another example. In this example, I will be going over different scenarios for buying a car. So we're basically just trying to figure out a better deal. Which one is better? Do you finance a car for $19,327 for 0% interest for 60 months? Or do you finance that same car for 7% annual interest rate and a $3,000 rebate? And this is something that is very applicable to real life, and you should know which deal would be better. So in order to figure this out, the easier example here would be to find the 0% interest for 60 months. So the 0% interest for 60 months, to find the payment, if you're not paying any extra interest on it, you can just take the total present value of 19,327 and divide it by the number of months. In this case, it's 60, which would give you a monthly payment of $322.12. So your payment for the 0% interest would be $322.12 per month for all 60 months. Now in this other scenario, we have the present value of the car not being $19,327. What we get to do instead is subtract the rebate. So this would be for scenario 1 over here. There we go. For the second scenario, the present value would only be the original present value minus the rebate. So with the rebate, you would get that amount knocked off the present value of the car, or the MSRP, or whatever you want to call it, the price of the car. So that would give us $16,327. So you can see how these scenarios would be different and why it may cause some confusion on the part of the consumer. So the first scenario is you can pay full price for the car and no interest, or if you knock off some money from the car, but now you have an interest rate, will that ultimately reduce the amount of money that you pay per month and thereby overall? Well, we have to do a little math to see how that works. There is another formula, go figure, to where we can figure out the payment of a present value annuity. And it looks something like this: 1 minus 1 plus I raised to the negative n power. There it is. So the formula that you learned a couple slides ago is just this formula solved for PMT for the payment. That being said, all we have to do is figure out I, and we already know what N is. 60 months, 60 total payments that you will be making on this car. So N is 60, and I, in this case, will be the 7% as a decimal, 0.07 divided by 12. That being said, we can substitute all of this into the equation. 0.07 over 12 divided by 1 minus 1 plus negative, let's see here, 0.07 over 12. We've got 60 here, and the payment, or rather the present value, is 16,327. So enter in the calculator to get a final answer of $323.29 per month. And at that point, you just have to look at the two different payments and figure out which one is lower. In this case, the lower payment will be the 0% for 60 months, the 0% full price car. Okay, but by how much? How much money will this actually save you? In order to answer that question, we just have to take the bigger amount minus the smaller amount. So we get some positive number. The savings would be $323.29 minus $322.12, leaving us with a whole $1.17 per month savings. And over the life of a loan that is maybe $65 over a 5-year span, you can decide for yourself if it would be better to, whichever one makes you feel better. The difference is not too much here, but again, mathematically, technically speaking, this answer here is going to be better and cheaper for you in the long run. A final few words to close out this video about house finance math, or the math behind financing a house. When you decide to buy a house, there will be a selling price, whatever the seller is selling for, and that will consist of a down payment and a present value. So when you add your down payment and your present value together, that'll give you the selling price of the house. I think another way to think about this that usually makes more sense to students or in the real world is if you take the down payment away from the selling price. That will give you your present value, aka your mortgage value. And again, this makes much more sense, I think, is that people are more interested in what they will have, how much money they'll have to borrow from a bank, and that's what the mortgage is to buy a house. And it also means if a friend tells you, well, I put a $25,000 down payment on the house and a $175,000 mortgage, then you know that the house sold for $200,000. So that's just a little bit that's there. You can go through and find the interest that was paid over the life of a mortgage simply by taking the payment and multiplying by the number of payments or the number of compounding periods, and then you can subtract the present value. And of course, the interest is going to be some obnoxious amount of money. Uh, in real life, the mortgage I have is for $140,000, and I think I'll end up paying $240,000 over 30 years. So it's like having a $100,000 interest bill, which is more or less saying, hey, bank, thanks for letting me borrow $140,000 for 30 years. Here is an extra $100,000 I'm going to pay to you extra to show my appreciation. So this is how you can figure it out, the interest and the selling price, or maybe what the present value would be. If you know the selling price in your down payment, you can find out how much the mortgage would be and then figure out payments from there even, because you'll know a present value, you'll know an interest rate. If you go into buying a mortgage and not knowing your interest rate, get out. That's not something that should happen. So you know your present value, which is your mortgage amount again. You'll know your interest rate. You'll know your term length, how many months you'll be paying on the mortgage, N in this case. So you can go through and figure out your payment for yourself and make sure that all of the math lines up. And that concludes everything for this video. I hope this financial math is starting to make a little more sense for everybody out there. Good luck.